All right, we're going to do course schedule 2 on LeetCode. So they give us a number of courses and they give us some prereqs. And in this list of prereqs, the course on the right is the prerequisite for the course on the left. So we have to take course 0 before we can take course 1. And in the output, they want us to return the ordering of the courses that we have to take to finish all the courses. So we're just going to depth first search through our courses. So we're going to create a graph out of our prereqs and then depth first search through it and then add the courses to our result. So before I start, we're going to create a variable up here. And this is just going to be an index into our result that we're going to return. So in the beginning, we'll just initialize this to num courses -1 because what we're going to do is when we're doing the depth first search at the end of our recursion, we're going to add the class to the end of our result, which is why I'm starting at num courses -1. And then we're going to decrement order as we're coming down from the recursion. So now let's create let's create the thing that we're going to return, right? Actually, let's just do that up here. So int result equals new int, and it's just going to be the number of courses. And we want to create an adjacency list out of our prereqs. So let's create that. And we need this adjacency list because we need to be able to loop through our neighbors efficiently in the DFS, in the depth first search. So new hash map. Cool. And now we want to populate this adjacency list with all of our nodes. So we're just going to loop through our courses plus I, and then going to put a new array list at each index or at each key for every course. So this is just mapping every course to its list of prerequisites or to the list of classes that this course is a prerequisite for. So this would be the prereq, and this would be the list of classes that it's a prereq for. Okay. So now let's loop through our prerequisites that they gave us. So for every, let's just say edge prerequisites, and what we want to do is add, or no, we want to get the thing on the right. So index 1. So this course is a prereq for edge at 0. So remember the thing on the left, which would be edge 0. This is the class that we take after doing the prerequisite. So this is the prerequisite right here. Okay, and then we're just adding we're just adding this to the array list that we created up here. All right, so now our adjacency list is populated. Now we need to DFS, and just so we're gonna go through. Let's see, what am I doing here? We're gonna go through our adjacency list. We're gonna go through every node in our adjacency list, and then we're gonna depth first search and then add the courses to our result. So for every, we'll just say course in adjacency list dot key set. So we're going through all the courses in our adjacency list. We're going to, actually don't need these brackets. We're going to try adding the course. So add the course. And if we weren't able to add the course to our result, so we're going to pass in the result here. And so if we weren't able to add the course to our result, then just return an empty array. Because in the they said if it's impossible to finish all the courses, then return an empty array. So that's why I'm returning an empty array here. And at the very end, we're going to return our result. Cool. So this is actually going to be our DFS method. So we're going to write that in a second. But before we get to that, we need to add a couple things. So we need to keep track of any nodes that any courses that we've already visited or any nodes that we've already visited in our graph. So let's call this visited equals new hash set, because we don't want to, if we visited the course already, we don't want to add it to our result multiple times, right? So that's why we got to keep track. And then we also need to keep track of any nodes that we've encountered while we're recursing. So I'm just going to call this stack nodes, and I'll explain why in a second. So this stack nodes, When we call add course, this is going to be a recursive depth first search, right? So while we're recursing, we need to keep track of all the nodes that we encounter while during that recursion. Because if we encounter the same node twice during that recursion, that means we have a cycle. And if we have a cycle, then that means that there are at least two classes that are a prerequisite for each other. And that means that it's impossible to take either course because they are prerequisites of each other. Okay, so which is, so that's why we have to keep track of what nodes we've hit during the recursion stack. So now let's pass in our visited, let's pass in our stack nodes, and I think we're good. Am I missing anything? I don't think so. Oh, or the adjacency list. Let's put that here, adjacency list. All right. So let's add this method. So private boolean add course, and this is going to be an integer. This is going to be the result, and adjacency list. This is going to be, just copy paste this. I don't want to type that. And let's actually put this on a new line because this is getting pretty long. And we need to have our stack, or not our stack, our set of visited nodes and our set of stack nodes. And let me put this on a new line. Cool. Okay, so we have our visited, we have our stack nodes. Cool. And now we can actually write this. So first thing we have to check is if we've encountered this course before. Or actually, you know what, let me call this something else. Let's call this stack courses. Yeah, I think that's a better variable name so it's more clear. So these are just the courses that we encounter during the recursion stack. So if stack courses contains the course, then this means that we've encountered this course before if it contains it. Which means that we have a cycle, so we want to return false. We don't, which returning false indicates that we have a cycle. And if we return false here, we're just going to return an empty array. Okay, cool. So now we want to check if we visited this course. So if this isn't contains, because it just contains. So if visited contains the course, so we visited this course, then just return true, because what this means is that we already added this course. We successfully added this course already, so don't bother checking this course again, or don't bother adding this course again. So now we are going to add to our recursion courses, or we're just going to add to the stack courses this course. So let's just add it, and then we're going to add it to the visited as well to mark it as visited. And then we're going to go through all of our neighbors, all of the neighboring courses, which just means that all of the courses that this course is a prerequisite for. So for every, what do we want to do first? Oh, actually we have to do one little check here. Before we get to that, we have to check if this course, actually wait. Never mind, sorry. Just keep going. For every course, or every, let's just say neighbor. For every neighbor in the adjacency list, .get course. So these are like the neighboring courses, or the courses that this course is a prerequisite for. Okay, so now let's recurse. So we're just going to continue the depth first search. So if we weren't able to add the course, or add the neighbor to our result, and pass in the adjacency list, pass in visited, pass in stack courses. So if we weren't able to add it, then just return false. And if we were able to add if we were able to add all the courses or all the neighbors, then just return true. And right before we return, so we're about to pop off this recursion stack, right, at the very end of this. So this is, once we're done with this recursion call, we need to remove the course from our stack courses. Okay. And So now we can run it. Let's see. Where did I mess up? Get rid of this. What's wrong with this? Oh, I didn't actually add anything to the result. Okay. So at the end of the recursion, oh, we're just gonna put it, so order, remember that was the variable I created up here. And then I set it to num courses -1. So once we're at the bottom of the recursion, so because we keep recursing here, right? So we're going to recurse, and once we hit the end of the recursion, then we can add that course to our result. So that's essentially, this is the very like last course you would take in your list of courses. So we can just go ahead and add it. And now then we want to post decrement the order for the next course that gets added here. Okay, so now let's run it. Okay, cool. It runs, submit. All right, and we're done. So now let's go over the time complexity. So this is just going to be O of V plus E because it's depth first search, and that's a pretty common time complexity. We're going through, well, we go through all the nodes here, right? And then we go through all the edges here. Yeah, so we go through all the edges here. So that's just going to end up being O of V plus E. So for space, it's going to be O of V plus E as well because of our adjacency list. Because we store all the nodes here, and then if there's edges, it could be, we add in all the edges as well. So it's O of V plus E for the space, and then because of the recursion, this is going to be O of basically if you think of this as like a tree, it would be the depth of the tree, but that can't be bigger than O of V plus E. So the space is upper bounded by O of V plus E at the end of the day. So yeah, if this video helped, you can give it a thumbs up, and you can subscribe if you want. Cool. Bye.